Okay, today's session we are going to discuss the basicity of amines, the most important topic in a competitive oriented basicity basicity of amines. That is aliphatic amines, and aromatic amines. Basicity of amines, aliphatic amines, and aromatic amines. We know that amines are the derivatives of amines are the derivatives of ammonia, NH3. Right. So ammonia contain lone pair of electron, lone pair of lone pair of electrons. So ammonia act as NH3 act as Lewis base. NH3 ammonia contain one lone pair. To donate the lone pair to electron deficient molecular ions or atoms, so NS3 act as a Lewis space. The lone pair donor is called the Lewis space. Simple acid base definition. Lone pair donor is called Lewis base, and the lone pair acceptor is called the Lewis acid. So ammonia molecule act as a Lewis base. So three hydrogens are replaced with alkyl groups. Primary amine also act as a Lewis base because one alkyl group is present on the nitrogen, and the secondary amines also act as a Lewis base, and tertiary amines tertiary amines also act as a Lewis base. So now comparison of primary, secondary, and tertiary amines with ammonia. So this is a concept in aliphatic amines. So which contain the more basicity? Is it ammonia or an okay, primary amine, secondary amine, and tertiary amine? So to say the basicity of amines, we have to consider the three factors. Factors affecting factors affecting on basicity factors affecting on basicity of ammonia basicity of ammonia and their derivatives their derivatives. First factor number one is electron donating groups. Electron donating electron donating alkyl groups. Electron donating alkyl groups, that is a plus I effect, inductive effect, plus I effect. Next factor, okay, now hydrogen bond with aqueous solutions. Hydrogen bond with aqueous solutions. Third factor is a steric factor, steric hindrance. Steric factor or steric hindrance. So these are the three factors influence on the basicity of the ammonia and amines. So now we go through the all the parameters affecting on the basicity of ammonia and amines. First factor is electron donating alkyl groups. Electron donating alkyl groups. If number of alkyl groups increases increases on nitrogen, the basicity of amines increases because basicity is directly proportional to the fundamental. Basicity is directly proportional to to the density. Electron density. So more is the number of alkyl groups on nitrogen, more is the basicity. So now basicity order R3N is greater than R2NH is greater than RNH2 is greater than NH3. If we consider the only factor of the electron donating groups, that is plus side effect, the basicity order is R3N, R2NH, RNH2 and NH3. Tertiary is greater than secondary, tertiary is greater than secondary is greater than primary is greater than ammonia. So this is the order according to the number of alkyl groups present on the nitrogen. Is it clear, students? Is it clear to all? Is it clear to all? Only I hear only one or two voice. Number of participants. Today number of participants are 19. Okay now. Next, factor number 2. Factor number 2, hydrogen bond with aqueous solvents or polar solvent. We call it is a hydrogen bond with polar solvents. Right. Hydrogen. So when ammonia is dissolved in, when or amines, ammonia or amines are dissolved in like a polar solvent, like polar solvent, it form like polar solvents, it form the hydrogen bonds dissolved in polar solvent can form hydrogen bond. More is a hydrogen atoms, more is a hydrogens on nitrogen, more is the ability to form hydrogen bond. Therefore, the amines, size of the amines increases. The size of the amines increases. So, number of hydrogens are more on the nitrogen, then it can form the more number of the hydrogen bonds. When it form the more number of the hydrogen bonds, it can form the bulky molecule. It can form a bulky molecule. So when the bulky molecule is formed, the basicity is decreased. So the size of the amines increases or it form bulky molecule. It form bulky molecule. Therefore, basicity of amines decreases. Basicity of amines decreases. Okay. Now. So basicity order is, what is the basicity order? number of alkyl groups, number of hydrogen present on the nitrogen is more. Okay, it can form the bulky molecule. So the basicity order is R3N is smaller than R2, NH is smaller than R, NH2 is smaller than NH3. Okay, because it is a bulky group. If it can form the no hydrogens are present, it is dissolved in water. With water, it can form the hydrogen bond. So the bulky molecule is formed here. So the basicity is decreases. Next, the same manner, factor number 3. Factor number 3 is a steric hindrance. More is the number of alkyl groups on the nitrogen, more is a steric hindrance. So the basicity also decreases. Factor number 3, steric hindrance. Steric hindrance, more is alkyl group, more is alkyl groups on the nitrogen, less is the ability, less is the ability to form a less is the ability to donate the lone pair of electrons. Less is the ability to donate donate the lone pair of electrons. Therefore, basicity is decreases. Basicity is decreases. So now, so here also what we take R3N is smaller than R2NH is smaller than RNH2 is smaller than NH3. Now factor 1, factor 2, factor 3. Girls, all you follow me? Girls, right. So factor 1, factor 2, factor 3. So these two factors, the order is 3 is less than, 2 is less than, 2 is less than, 1 is less than ammonia. And the factor 1 is 3 is greater than, 2 is greater than, 1 is greater than ammonia. So this is a conclusion about the factor 1 and the factor 2 and 3. So factor 1 is opposing the factor 2 and 3. This is a conclusion. Otherwise factor 2 and 3 opposing the factor 1. So here order is more is the number of alkyl groups, more is a plus I effect, more is a basicity. So that we will get the 3 is greater than, 2 is greater than 1. But in the second factor and third factor, when ammonia is dissolved in water or like a polar solvent, it can form the more number of hydrogen bonds. When the more number of hydrogen bond is formed, okay, the stability of the amines are increases so that it unable to donate the lone pair of electron. So basicity is decrease. In the same method, factor number 3, more is the number of bulkiest alkyl group. Okay, bulkiest alkyl groups present on the nitrogen due to the steric hindrance, the basicity is decreases. So the order is 3 is greater than, sorry, 3 is smaller than, 2 is smaller than, 1 is smaller than the ammonia. So from the factor 1 and factor 2 and 3, 2 and 3 almost give the same information, but factor 1 is opposing the 2 and 3. So the conclusion of the basicity of the order is, from these three factors we concluded that the basicity order of amines and ammonia is the basicity order of amines and ammonia in a gas phase. In gas phase, all are present in a gas state. Remember this point. In a gaseous phase, tertiary amines is greater than, secondary amines is greater than, primary amines is greater than ammonia. 3 degree is greater than 2 degree is greater than, primary is greater than ammonia. When primary, secondary and tertiary amines are present in gas phase. All are present in gas phase. All are present in gas phase. If ammonia, primary alkyl, okay, primary amines, secondary amines and tertiary amines present in a polar solvents, and nitrogen is bond with a smaller alkyl group like only methyl. See here, the basicity order of amines in polar solvents, basicity of amines in polar solvent. So this is polar solvent can form the hydrogen bond. So the order is secondary amine is greater than primary amine is greater than tertiary amine is greater than ammonia. When R is equal to methyl CH3 only, R is equal to CH3 only, not a bulky groups, only basic alkyl group, that is a NH3. Oh no, sorry, CH3, only CH3. Only CH3 is attached to the nitrogen, then basicity order is secondary is greater than, okay, now primary is greater than, tertiary is greater than ammonia. 213. The order is 213. In gas phase, no doubt at all, here we consider the only plus I effect. We consider here only plus I effect. In a gas phase, no hydrogen bond. It doesn't dissolve in the polar solvent. It is present in the gaseous state. That's why there is no possibility of the hydrogen bond. Then only plus I effect can influence on the basicity of the ammonia. That's why we will get a 3 is greater than, 2 is greater than, 1 is greater than ammonia. 321. Simply we call it is highest number because it is present in a gas phase. 321 is greater than ammonia. Like that. Now the amines are dissolved in a polar solvent, otherwise a water. The order is little bit different. That is when R is equal to alkyl group. That alkyl group may be a only methyl group, only the smallest alkyl group. Then 213 is greater than NH3. That is secondary is greater than, primary is greater than, tertiary is greater than ammonia. If alkyl, okay, now if R is equal to other than the methyl group, like a C2H5 or R is equal to C3H7, bulkiest groups present on the nitrogen, then order is 231. That is 231 means here R2NH is greater than R3NH is greater than RNH2 is greater than NH3. Got it? Are you follow me, girls? Is it clear to all? That is a 231. Most of the people get confused how to remember this order. Only if it is a gas phase, only plus I effect, no water is present here and no polar solvent is present, only plus I effect, more is a electron releasing groups, more is a basicity. So 321, right? 3 degrees greater than, 2 degrees greater than, primary is greater than, okay, amine. Now when the amines are dissolved in a polar solvents, then the group is the smallest group. The group is smallest group. The group is a small, okay, no, highest group. Smallest group has a smallest number 213. If the group is a largest number, that is the largest number 231. 213, 231. Got it? Is it clear to all? 213 in R is equal to methyl, lowest number. Next 231 in R is equal to bulkiest groups. Got it, Amma? Is it clear to all? Hello. Next, basicity. Basicity of the amines is expressed in the equation. We can write basicity of amines. See here, RNH2 plus H2O gives what you get here? It gives the hydrogen RNH3, RNH3 plus OH minus. Now, dissociation constant Kb, dissociation constant Kb of this equation, Kb is equal to concentration of RNH3 plus into concentration of OH minus by concentration of RNH2 or NH2, because H2O we don't, because water is an excess quantity, that is Kb. Got it? So, in acid base chapter, we know the one relation Kb is inversely proportional to the pKb. Right? pKb is equal to negative logarithm of Kb value. Negative logarithm of Kb value. This is the expression for the Kb and Ka and pKb values. So, some values are given here. Values we don't require, but only you have to remember the basicity of the amines expressed in Kb, that is the dissociation constant of the equation, right? Because all of the weak bases, not a strong basis, but of the weak bases, we discuss their order, that is RNH2. If it is dissolved in a water, it is a polar solvent, gives RNH3 plus. It is the lowest base. This is a base. This one is acid. Okay, a base has a strongest conjugate base. This is a strongest conjugate base, and a weak acid has a strong base as a acid. So strongest conjugate acid, and acid, weak acid has a strongest conjugate base. Right, this is a conjugate acid base. Uh, base, and the Kb value is equal to concentration of the products by concentration of the reactants. So here we don't consider the H2O concentration. H2O concentration is excess. So RNS3 plus into concentration of the OH minus by concentration of RNH2. So the relation is Kb is inversely proportional to the pKb, and the pKb is equal to minus log of Kb. So more is the Kb value, more is the Kb value, more is the Kb value, more is the basicity, more is the basicity, and vice versa. More is the basicity and vice, vice versa. And more is the pKb value, more is the pKb value, more is the pKb value, less is the basicity, less is the basicity, and vice versa. So this is about the basicity of amines. Okay, basicity of amines and their order in a gas phase and in a polar solvents. In a gas phase, 3 is greater than, 2 is greater than, 1 is greater than ammonia, and in a polar solvents, in a aqueous solution, if R is equal to methyl group, then the order is secondary is greater than, primary is greater than, tertiary is greater than ammonia. That is 213 is greater than ammonia. If R is equal to bulky group like ethyl isopropyl, propyl, butyl isobutyl, so then basicity order is a secondary amines is greater than, tertiary is greater than, primary is greater than ammonia. That is a 231 is greater than NH3. Like that you have to remember. Now, basicity of basicity of aromatic amines. Aromatic amines. Aromatic amines, in this case, we consider one of benzene possesses NH2. It is called a aniline. So here also one lone pair of electron is present. And NN, okay, N-methyl aniline, N-methyl aniline, and NN dimethyl aniline, NN dimethyl aniline, and ammonia. Right. So the this one is N-methyl aniline or benzene amine, N-methyl benzene amine. This is NN dimethyl aniline or benzene amine. So from these three, the basicity order, usually ammonia is greater than aniline. Ammonia is greater than aniline because this lone pair of electrons involved in a resonance, that is called the plus CM effect. So already we discussed in the benzene chapter and the previous alcohol chapter. Next acid base, carboxylic acids, either topic. So aniline, so lone pair of electron involved in the benzene resonance, that is a plus CM effect. So due to the lone pair of electrons into the benzene, the basicity is decreased. The ability to donate the pair of electron to any protons or electron deficient is called the basicity. If it is ready to donate the lone pairs, it is a strong base. If it is unable to donate the lone pair, it is a weak base. So compared to ammonia and aniline, ammonia is a strongest base because this lone pair electron directly donate to the electron deficient molecule. But this lone pair of electron are unable to donate the electron deficient molecule because this lone pair of electrons involved in a resonance, that is a plus M effect. So usually NS3 is greater than aniline. Now among these three basicity order is okay. Now so number of alkyl groups increases on the nitrogen. So basicity order is, this is a 3-degree amine, this is 2-degree amine. Let us take this a primary amine. So 3-degree is greater than 2-degree is greater than primary. This is the order of the okay aromatic amines. That is NN dimethyl aniline 3-degree amine and N-methyl aniline is greater than aniline. Got it, Amma? Because aniline don't have a alkyl group. So here plus M and plus I. So plus M regarding to the lone pair of electron is sending to the benzene. All cases one lone pair is present, equal probability, but second case and third case, 3-degree and 2-degree and 3-degree, yeah, the two alkyl groups are present, it acts as a plus I effect. Number of alkyl groups increases, the electron density increases on the nitrogen, so basicity is increased. That's why 3-degree is greater than 2-degree is greater than primary, that is NN dimethyl is greater than N-methyl aniline is greater than aniline. Okay, this is the order of the aromatic amines and aliphatic amines, basicity order of the aromatic and aliphatic amines. Clear, Amma? Is it clear to all? Students, is it clear to all? Any doubt regarding this topic? Any doubt? Okay. Okay, almost time is up. We have the 5 minutes, almost 10 minutes left. The next one is, yeah, one more concept is there, right? Basicity of the electron withdrawing group and electron donating groups present on the benzene. So basicity basicity of amines with electron donating groups and electron withdrawing groups present on benzene. Let us take here aniline NO2 group is present on the ortho position. NO2 group is present on the meta position, and the NO2 group is present on the para position. So, okay, NO2 is the electron withdrawing group, and here no group is present on the aniline, NH2. Right. NO2 group is the electron withdrawing group. Already we know it decreases the electron density of the benzene nucleus. Right, benzene nucleus. Benzene nucleus. So the what is order? This is the first structure, second, third, and fourth one. What is the basicity order? Without any group. Okay, without electron withdrawing, it contains the more basic in nature. Right, one is greater than. Okay, electron withdrawing group is present on the ortho position. Electron withdrawing group is present on the meta position. Electron withdrawing group is present on the para position. When electron withdrawing group is present on the ortho position, it is NO2 and it is a minus I. Okay, minus M effect. Minus M effect. And here also minus M. Nothing but a minus R. Okay, negative mesomeric effect. But electron withdrawing group is present on the meta position. We consider it is only minus I only. We don't consider the minus M. So when I affect and I and M both are in a competition, so we consider I is smaller than M. I is smaller than M. Inductive effect is smaller than the mesomeric effect. Otherwise, the mesomeric effect is greater than the inductive effect. Here the group is electron withdrawing group. Electron withdrawing group is inversely proportional to basicity because it decreases the electron density on the benzene nucleus. So electron withdrawing group is inversely proportional to basicity. So this also electron withdrawing group in this one and this one, but here NO2 act as a I group, and here in these two cases NO2 act as a M group. So 1 is greater than 3. 1 is greater than 3. Okay, now basicity order, because these two are the weak bases. These two are the weak bases. This is a more base. Next one more base. Next one 4 and 1. Okay, now 4 and 2 both are in a competition. 4 and 2. NO2 group is present on ortho and NO2 group is present on the para. Both are the minus M groups. But in this case, the same group is present on the ortho, para and meta position. Ortho effect, what we consider here, ortho effect. So if electron withdrawing group is present on the ortho position, more is withdrawing in nature. So the basicity is completely decreases here. So 4 is greater than 2. This is a exactly order of the electron withdrawing groups present on the benzene nucleus. Got it, Amma? Is it clear to all? Next, basicity amines with electron donating groups. Let us take electron donating groups with NH2. This is structure number 1, and NH2 methyl is present on the ortho electron donating group, and methyl is present on the meta position, and methyl is present on the para position. Methyl is present on the para position. Right. So we know electron withdrawing, electron donating group is directly proportional to basicity because electron density is increases on the nitrogen. Right. So aniline, methyl, orthomethyl aniline and metamethyl aniline and paramethyl aniline. So nothing will be there here. Electron withdrawing group required here. This is weak base. The structure number 1 is a weak base, no doubt at all. Weak base. So I am writing decreasing order. Highest number to the lowest number. Highest one is ortho effect. Due to the ortho effect. Here also ortho effect. This is electron withdrawing. That's it in the least position. But it is electron donating group. This is highest position. Second is greater than. Okay, now meta position methyl group is present. Para position methyl group is present. This is a highest impact. Plus I effect is more here, but here plus I effect is less. That's why we take here 2 is greater than 4 is greater than